Hi everyone, welcome back. So, this is the third video in which we'll be knowing how to solve quadratic equations based on quadratic formula. In the process of solving the quadratic equations, we know that there are three methods. First method is factorization method that we studied. Second method was making a complete square that also we studied. This is the third video about solving a quadratic equation, and in this we'll be learning about quadratic formula. Okay, see, any three methods you can always solve any quadratic equation with any other three methods. Okay, and obviously every time the roots will be same only, it will not be different. Okay, by whatever method you choose you will always get the same roots, but you know it is not always feasible to find the factors of the given quadratic equation. Okay, so this method will help you sometimes only when you have correct factors, if you can identify the factors of the given equation. Second thing, making it a complete square is also fine, but it is quite cumbersome, like you have to put efforts, make it complete square and then find the solution. Okay, but this third method is quadratic formula. This you can always use to find the roots. Okay, this is the most convenient method. We will see what the formula is. We'll just see the derivation of the formula, and once we derive the formula it will be very simple to find the roots of any quadratic equation. So without wasting any time, let us see what the formula is. Say I have a quadratic equation ax square plus bx plus c equals to 0, whereas you know a is not equal to 0. Okay, let me try to generalize the solution of this. Okay, I will take the use of this second method, making it a complete square. So as per the process, what I'll do, I have to make this coefficient equal to 1, so I'll take out a common. Remaining is x square plus b by ax plus of c by a equals to 0. So finally my equation becomes x square plus of b by ax plus of c by a equals to 0. Okay, so I know that the roots of this and the roots of this will be same. So now what I'll do, I'll try to make it a perfect square. This I already have x whole square. Here I will write 2 into a is my x, and capital B, the second term will be b by a. So I have 2ab, and since I'm multiplying this with b by a, I have to write the third term, that is b by a whole square. Since I'm adding this term, I have to subtract the same term, b by a whole square, and the last term plus c by a, I'll write it as it is. Okay, can you relate this to the formula? This is my a square plus 2 into a into b plus of b square and remaining terms. Okay, now this three terms will together give me a plus b whole square. Got it? Yeah, so that is why we wrote it in this format. Now let us see what do we get it here. Okay, once we have made it perfectly, then we can easily find a general formula for the roots. So this becomes x plus, is it correct or is there any mistake? Can you tell me? Yeah, there is a mistake. See this term and see this term. Are both of them same? Here we have an additional 2. Okay, so I do not have to multiply it with b by a. Instead of this, I have to multiply this term with b by 2a. Then only this 2 and this 2 will get cancelled and I have b by ax as it is. Okay, so my second term is not just b by a, it is b by 2a. So I'll add b by 2a whole square, subtract b by 2a whole square. Okay, understood the mistake? Okay, now let us continue the video. So then we have x plus b by 2a whole square minus of b by 2a whole square plus of c by a equals to 0. Okay, so this becomes x plus b by 2a whole square is equal to, I'll take both these terms on RHS, so this becomes b square by 4a square minus of c by a. Okay, very simple. Now let us see what do we get after further simplification. This becomes x plus b by 2a whole square is equal to b square minus 4ac by 4a square. Okay, so when I'll remove the roots, I have two solutions, that is x plus b by 2a is equal to plus of under root of b square minus 4ac by 2a, because under root of 4a square is 2a, or x plus b by 2a is minus of under root of b square minus 4ac by 2a. Okay, so from here my solution will be x equals to minus of b by 2a plus of under root of b square minus 4ac by 2a, and from here the solution will be minus of b by 2a minus of under root of b square minus 4ac by 2a. Got it? So these are both of my roots. When I'll try to write them together, I can write it as x is equal to minus of b plus or minus under root of b square minus 4ac divided by 2a. Now this is the formula of finding the roots for an equation, and this is known as quadratic formula. Okay, and this is also known as Shri Dharacharya's rule or formula. Okay, so basically this is the formula that you need to remember for finding the roots of any quadratic equation. Okay, x is equal to minus b plus or minus under root of b square minus 4ac divided by 2a. Okay, now you know that in real numbers the quantity inside the root should be non-negative. Am I right? Yes, the quantity inside the root should be non-negative. Okay, so based on that, if the roots are real, the quantity inside the root, that is b square minus 4ac, that should be either equal to 0 or greater than 0. Okay, this quantity that is written inside the root b square minus 4ac is known as discriminant. Okay, this quantity is known as discriminant, denoted by capital D. So I can write the same formula as x equals to minus b plus minus root of d by 2a. Okay, where d is equal to b square minus 4ac. We'll see about d later on in coming set of videos, that is nature of roots. As of now, we'll just concentrate on the formula. Okay, so let us now see some examples in which it will be clear how to apply this formula. Okay, let us start with a very basic example. Suppose the question is 9x square plus of 7x minus of 2 is equal to 0. I need to find the roots of the given equation using quadratic formula. Now I will relate this to ax square plus bx plus c equals to 0, and I know the formula is minus of b plus minus under root of d by 2a, where d is equal to b square minus 4ac. So let me try to find the value of d first. Here a is equal to 9, b is equal to 7, and c is equal to minus 2. Let me substitute into the formula. 7 square minus 4 into 9 into minus 2. Okay, this will come out to be 121. So x is equal to minus of 7 plus or minus under root of 121 by 2 into 9. Okay, so from here I can write x is equal to minus 7 plus or minus 11 by 18, which gives me that x is either equal to minus 7 plus 11 by 18 or minus 7 minus 11 by 18. This implies x is either equal to 2 by 9 or x is either equal to minus 1. Hence 2 by 9 and minus 1 are the roots of the given quadratic equation. Okay, so let me take another example. Suppose the equation is 25x square plus 20x plus 7 equals to 0, and I need to find the roots. Okay, so what is the value of a here? A is 25, B is 20, and C is 7. Okay, so I know that the roots will be given as minus B plus or minus root D by 2A, where D is equal to B square minus 4AC. So let us try to find the value of D. So 20 square minus of 4 into 25 into 7, which is equal to 400 minus of 700, which is equal to minus 300. Okay, now this quantity is less than 0. Okay, now you know that anything inside the root should be non-negative for it to be defined. Now we are getting a negative quantity here, hence our under root quantity, that is root of minus 300, will not be defined. Hence this equation will have no real roots. Hence you don't need to solve it further because no real roots exist for this. Okay, hence this is very important that whenever you need to find the roots using quadratic formula, first of all find D. If D is non-negative, then only try to find the roots. If it is negative, then you can directly say that there are no real roots possible for this given quadratic polynomial. Okay, let me take a last example. Say I have a quadratic equation 9x square minus of 9 times a plus bx plus of 2a square plus of 5ab plus of 2b square equals to 0. Now I need to find the roots. Okay, so I will try to relate it to the initial quadratic equation capital Ax square plus capital Bx plus capital C equals to 0. Okay, so if I relate them, capital A is equal to 9, B is equal to minus 9, A plus B, and C, capital C, is equal to 2A square plus of 5AB plus of 2B square. So let me try to find the value of capital D. Capital D is what? B square minus 4AC, which is equal to minus 9 times A plus B whole square minus of 4 into 9 into 2A square plus 5AB plus of 2B square. Okay, so this will come out to be 81 A square plus B square plus 2AB minus of 36 2A square plus 5AB plus of 2B square. When you will simplify this, you will get the final expression as 9A square minus of 18AB plus of 9B square. I'll take out 9 common. That will become A square minus 2AB plus of B square, which is nothing but 9 times A minus B whole square. Okay, now 9 is positive, A minus B is non-negative, hence this is valid. So our D is valid. Now we'll approach to finding the roots. So the roots will be given as minus of B plus or minus root D by 2 times A. So I'll put the values minus of minus 9 A plus B plus of minus plus or minus 9 times A minus B whole square divided by 2 into 9. This is equal to 9 A plus B plus or minus of 3 times A minus B divided by 18. Okay, so from this we'll get the two roots as 2A plus B by 3, or x is equal to A plus 2B by 3. Hence these are the roots of the given quadratic equations. So now I think that you might have a clear picture how to find the roots of a quadratic equation using quadratic formula. The formula is really very simple and you can apply it for any set of quadratic equations. Okay, so I hope you liked the concept, you understood it very well. Like the video, please like the video, share it among your friends, and please subscribe our channel for more updates regarding new concepts and new videos. Thank you for watching. Have a nice day. Thank you.